Hi there. So today we have an iPod Touch 5th Gen that came in here for a very interesting charging issue. When we hook it up to a charger, it will show the Apple logo and try to boot up. Then it fails and goes back to the battery logo with also an indicator to plug in the charger, even while the charger is plugged in. So I'm kind of afraid that this is going to be either a charge port issue or worst case scenario, a motherboard issue. I'm not sure if ZXW actually has any information about the iPod Touches, but typically when it comes to board repair, it's not really cost effective on the iPod Touches. So what we're going to try first is a Hail Mary. We'll try a battery. I don't think a battery will fix it, but we'll try just because it is a 5th gen. These are older and are common for battery failure after this time. And then if that doesn't work, we'll go ahead and we'll replace the charge port. The charge port's soldered on to the logic board, so that's why this is a micro soldering repair. If replacing the charge port still doesn't resolve the issue, we're going to have to look into the motherboard. Before we get into that point, though, we have to find out if ZXW even has access to fixing the iPod Touches, iPod Touch 5th Gen specifically. So let's get down into it. So to show you the issue that we got going on here, I'm going to go ahead and plug in our charger, and you'll see that the Apple logo, it turns on. And it turns on for a brief moment, and then shuts off. And to me, that's usually an indicator, well, the battery's failing. But what's so odd about this one is once the battery or the whole iPod shuts off, we get, it's hard to see because it's very dim. We got a battery logo and we have the connect to charger logo. And you usually don't get that if the charger is actually plugged in. Usually you would get just a battery logo by itself. So something is not communicating from the charge port to the charging circuit, whatever the equivalent of TriStar is on this iPod Touch. And we're just going to have to go ahead and open it up. What's fun about the iPod Touches, and I say that reluctantly, is there's no screws. This is all glued together. This is very, very similar to an iPad. The screen is glued to a frame, and we have to remove the screen from a frame and then remove the frame from the rest of the housing itself. So we're going to use our quick here and just go around the bottom of the iPod with some heat. And once it's nice and hot to the touch, we'll then take a pry tool. In this case, I'm just going to use a hobby knife and wedge it underneath the screen and start lifting up. If you decide to do this repair yourself, when it comes to heating up the iPod Touch, do not leave the heat gun in one isolated spot because we're right next to the LCD. If you do that, you'll actually melt the digitizer or you'll even melt the LCD and cause a permanent burn mark. Actually, what I'm going to do for this one, I'm going to treat it like it is an iPad. So I'm going to use our Wagner heat gun instead of our Quick. The Wagner is going to have a larger surface area to heat up. The Quick is really good for isolated heating, but we don't want to have isolated heating in this case. We want to evenly heat up the entire screen. So like you've seen in previous videos, this is just a standard Wagner heat gun. You can get it from Lowe's, Home Depot. This one we got from Hobby Lobby. And how we treat iPads is we heat up the entire screen, not just one part. So I'm going to treat this like it was an iPad. I'm just going to heat up the entire screen, go around in a circle, putting an emphasis on the bezels. That's where all of our adhesive's at. That's a good starting temperature for now. Alright, so we got our hobby knife wedged in there just a little bit. We're not going to force the screen. We're going to apply some more heat. The tension of the hobby knife being in there while applying heat will cause the adhesive around the hobby knife to separate from the screen and begin to lift up. once we can get a little bit further and get some slack from the screen and the adhesive, we're going to take a pick. This is an iFixit pick. It's not a standard guitar pick. It's made out of a different type of material that's more heat resistant than a guitar pick is. And our pick just came out, but we broke a good bit of the adhesive down here, so we should be able to cut right into the screen or lift the screen up easier. See? Just like that. I'm actually going to grab another pick. And since our screen's cooled down a little bit more, I'm going to go ahead and heat up the screen again. And won't have to do it as long like we did the first time because the screen was already a little warm. Another thing too, when heating up the screen, be careful around this home button. The home button is just made out of plastic, and it'll melt if you apply too much heat. Alright, so we've broken all the adhesive at the bottom of the screen. We got a lot of tension right here. We need to relieve some of that tension. So just like the hobby knife before, we have our pick in there. We're going to apply some heat to the screen, and the sheer bowing tension of the screen is going to lift up when heat is applied. And now we're going to take just a little part of our pick and run up the screen. Don't dig in too deep or else you'll puncture the LCD. We're just going up the glass. So we got that side lifted up. Let's move on to the other side. And once you can feel that there's some tension and you have to apply just a little bit more pressure, stop where you're at and heat up the screen some more. So we got some tension right here, or some pressure. So we've already released the bottom part of the screen, and about half of the way up, you know, apply a little bit more heat to the top. And now it's cutting through like it's sweet margarine, sweet butter. Okay, now the frame itself, I can see the frame is starting to separate right here. I'm going to see if I can just wedge my pick in and start pulling up the frame. Pick's bending too much. Let's try using our hobby knife. There we go. And so what we did is we separated the glass from the frame, because the frame is clipped into the housing, this rose gold housing of the iPod itself. So the screen is glued on top of the frame, and then the frame is clipped into the housing. So you need to separate the screen from the frame, and then the frame from the housing. And this is identical to an iPod 6th Gen. I think on the iPod 6th Gen, they updated some specs on it. It's a little bit better of a processor. iPod 6 does support a higher operating system than iOS 9. The iPod 5 only goes to iOS 9. I think it's because it's a 32-bit processor, and everything after iOS 9 is 64-bit based. I might be wrong about that, but I think that's the reason why this only goes to iOS 9. iOS 9. Okay, so now that we have removed, see, we've separated the glass from the frame, and we pulled the frame out of the housing, the top part of our screen has came out as well. There's a lot more adhesive on the glass to the frame, so we're just going to leave that alone. We really just needed to lift up 3/4 of the screen. Now we have a heat plate, or EMI shield, underneath the screen, and this just comes out with standard Phillips screwdrivers. I'm gonna set this back down temporary. We're gonna need a screw tray. Now we'll remove the Phillips screws. So our screws are removed. Now before we actually remove the plate itself, let me see if I can try to get that in the camera. The home button actuator is a flex cable that is part of the charge port in this one. At least I believe it is. And it goes through this hole right here and then wraps onto the plate. So we have to lift this up first and feed it through that hole so that we don't damage the home button actuator in the process. And our pick's just a little bit too thick, so I'm going to use our hobby knife and just be very careful not to rip anything in the process. And just like that, we lifted it straight up, and now the plate is going to come out. Now I'm going to take our hobby knife and just grab the side and lift straight out. Just like that. And just so we don't lose any screws, I'm going to set this stuff to the side. Immediately looking inside of this iPod, I don't see any signs of liquid damage, so that's good. So our battery is soldered underneath this little black metal tape, and then our charge port is soldered underneath here. The battery only has 3 connections, so we're going to do that first. We're not going to pull out the battery, we're just going to float the new battery in, soldered on. And if that doesn't work, then we need to address the charge port. There's more likely going to be a charge port issue, but since we're right here, we'll start with the easiest step. So I'm going to switch over to the microscope camera for this for a better view. Alright, so this is nothing more than just like a metal type of tape. I'm not sure what the sole purpose of it is, but we're going to have to remove it to expose our solder joints. And just because we're dealing with circuitry with the battery still plugged in, what I'm going to do is I'm going to take our heat gun, or in this case, our rework station, our quick rework station, and I'm going to apply some heat to this metal shield because it's held down with nothing but adhesive. After then, I'm going to take my iFixit pick and wedge it under to separate the metal tape from the rest of the board, just to be precautious. Alright, so now that that's removed, you can see our 3 solder joints a lot better. I'll save that. I'm not sure what it is. It's just like a metal tape. I'm going to save that to the side for now. Now the battery itself is going to have a small amount of Kapton tape on top of it. We'll take our tweezers and we'll remove that. And we're going to put some new Kapton tape, so I'm just going to trash this. Now for this to come off easier, we're going to be using a mixture of our rework station and our soldering iron. Actually, no, we're just going to use our soldering iron. So we'll put a little bit of flux over our mounds we have, or over our points that we're going to turn into mounds. I just put some flux onto the tip of my tweezers, just so I can get a small amount. I'm going to turn on our fume extractor, and now we get our soldering iron and some solder. Oh, and technical difficulties. Okay. And what we're going to do is just put a mound of solder, just like that, over our connection. And what this is doing is we're applying a new type of solder that will melt at a lower temperature. So then you can either take your rework station and heat this up and then lift it up, or you can take your tweezers. Let's see. Oh, there's also glue on here. Okay, so we are going to have to use our rework station. I've done this repair several times, but it doesn't come in often enough for me to remember each individual step. I have our rework station on very low heat. It should be just enough heat for me to get under here. Yeah, just like that, to remove our adhesive. Okay. And we could continue to use our rework station to lift up the components. I don't want to swish flux around everywhere. So what I'm going to do now is I'm going to take the tweezer and hold the left side. And I'll take our soldering iron and lift up, just like that, kind of peel it back. And continuing to heat it up with our soldering iron so that it loosens up. Do that to the middle one, and then we'll do that to the last one. And we'll just move everything out to the side. So there's our connection. So we got our what's left of our solder mounts and some adhesive. I'm going to get a little bit more flux to touch this up. Actually, what we're going to do, we're going to wick this up, and we're going to put some better solder on here. And while the adhesive is still warm, I'm going to take some isopropyl alcohol and swab around the adhesive. And adhesive really doesn't serve too much of a purpose other than to make sure that the battery connection doesn't rip off. Being that it's soldered on there, that's a good enough connection in itself. Nice, clean connection. Now that we're done with that, let's prep it again. Let's put some new flux, some more mounds of solder, and we're going to float in our new battery. Well, we're going to solder in the battery, but we're not going to remove this battery. We're just going to put the battery on top of it. This battery is glued in. We'll probably have to end up removing it anyways if it is a charge port replacement. Just for quick testing purposes, we'll see if this fixes it. So, new mound. I don't like that bottom one. There we go. Let's grab our new battery now. I'm going to leave this battery hanging out on the side. It's not pretty. We don't want it to look pretty for now. We just want to test and see if this fixes the issue. So we have our battery hanging out to the side. Let's see if we can get this guy to turn on now. We have the Apple logo. And we're going to have one or two things. Either the repair is fixed because it needs a battery, and then we'll finish installing it, or this is going to power on, but it's still not going to charge because we have an underlying charge port or logic board issue. This battery should have enough charge to turn on all the way. In fact, actually, let's go ahead and let's grab a charger. See if it boots up all the way first. Then we'll plug our charger in. Alright, so it's booted up. Looks like it has about 70% health. Alright, so I have the charger plugged in, but it doesn't look like it's acknowledging the charger. And just to verify, I'm going to have to go off screen for a second. We have a USB ammeter, and it helps us determine how much amperage is being pulled from the charger itself to the, from the charger itself to the iPod. Couldn't remember what this device was called for a second. The reason I have to just go off screen for a second is because we don't have a long enough cable. So our USB ammeter is showing no amperage consumption. So the battery is not the issue. The issue is going to be with either the charge port now or with something on the logic board. And this is a very, very small logic board. Let's remove the battery. We'll have to solder on a new charge port, just like we did. We floated it in. See if that resolves the issue. Turn our fume extractor back on. Our solder connections are going to come off very easy now, just because we have the new solder instead of the factory solder. We know this is a good battery now, though. I haven't been able to test this one out. So that's good to keep for future references. We're not going to solder the battery back on now. We'll do that after we solder on the charge port. Charge port has a very similar situation going on. It's not a metal type of tape, but it is some sort of mesh tape covering all the contact points. And it's adhered down as well. We can use our metal tweezers if we want, since we have our battery unplugged, so there's no power going through here. I'm going to do my heat and pick method, though. I am using a low heat, by the way. That's why I'm not too cautious about heating right next to the battery. Okay, that looks good. And I say look good because I can see part of the adhesive is actually starting to bubble up, like it's getting air in it. And looking at the type of material, this mesh material, it actually looks like it has a layer of, I'm assuming, Kapton tape. And it's some sort of anti-static adhesive. We're having to tug a little harder than I like, but it's coming along. Could have used a little bit more heat to remove this. Let's see, I'm just going to grab this with my fingers. It's coming off nicely. Our charge port has many more solder points than our battery does. That's why we did the battery first. And just like the battery, we have some sort of Kapton tape over the connections. Okay, so at this point we can do one or two things. We could either float our charge port on top of all of these solder points and test it out that way. Being that I have a pretty good feeling more than likely the charge port itself is the issue. I want to cross my fingers it's not a motherboard issue. I'm going to remove the charge port and solder the new one in its place. Well, let's go ahead and get into it. This one might have adhesive underneath it just like the battery did. I'm going to feel for it. And it does feel like there's a little bit of adhesive. So first, I'm going to apply some heat. That should be enough heat for now. Now we'll take some flux and cover our connections, and we're going to run a ball of solder over all of our points here. For this one, we will use the reflow station to pull up, just so we don't potentially pull up any traces in the process. So we'll take our soldering iron with a little bit of solder, and this is really cool. You can just get a nice little ball of solder like that, and just go over all your connections. If you have enough flux, this will bond to all your solder points pretty quickly. And we don't have enough flux. We're getting some pretty dirty connections. Let's get some more flux here. Looks better. Let's do that again. We're just kind of going back and forth over all of our connections with that ball of solder we originally had. So that looks good for what we're needing it for. We're going to have to turn up our rework station to a little higher temperature. And being that the battery was fine, we actually need to cover this battery up. What can we use to cover this battery up? I have a piece of cardboard over here. And this is just going to act as a heat barrier. Set that right over the battery itself. Actually, let's use something a little bit more heat resistant than cardboard. And cardboard smells when it's heated up. I actually got a silicone mat. I always forget about this mat because we never use it. And it's exactly like it sounds. It is just a silicone mat. You can use this for reworking, but this makes this a great heat barrier as well. So our connection is good to be heated up now. I'm just going to rock back and forth until we see the solder connections begin to melt. Then we can take our tweezers and pull up on the connection itself. Let's use a little bit more heat. Let's use 380. That should melt this pretty fast. Everything's just We're using the tweezers and we're pulling up at the same time as we see the solder joints melt. Our silicone mat's working against us right now, so let's move that to the side. There we are. Just a little bit in the way. And off comes our charge port. All of our pads are still in place. We won't need our silicone mat anymore. We'll move that to the side for the time being. We're going to wick up all of those rough solder looking connections. And while the adhesive is still hot, just like we did with our battery connection, we'll take some isopropyl alcohol into a Q-tip and just kind of go around in a circle to remove it. I've heard some people use acetone to remove flux and adhesive. I'm not sure what that would do to this fiberglass board. I personally just use a high-grade isopropyl alcohol. That's good looking. Our connections are pretty bare now, so we're gonna have to apply some solder mounds onto them. Some new solder, not the factory solder that's on there. Like before, we'll take some flux. Oh, we got it on our tweezers here, and we're just gonna put a good amount of flux here. Then we'll take our solder and our iron, make a good ball, and just kind of go down, heating up each pad. Just like that. So all of our pads are properly tinned and ready to go. I'm going to clean some of the flux that we just put on there. Now we're going to put a little bit more flux. There's no such thing as too much flux. Just so we got rid of the dirty looking flux. And I'm using a thin amount of flux this time, because we're going to put some flux on top of our connector itself. And just to show you what the charge port looks like on this guy, because it has a lot of connections. This is it right here, and our home button is attached to the charge port on this model. So the charge port goes underneath the battery. It lays like this, actually. It goes underneath the battery and then folds over on top of the logic board like so. So if it is a charge port, we are going to have to pull out the battery anyways. Everything okay? Okay. So back to what we were doing earlier. When it comes to aligning a flex cable, such as a charge port, we're going to have to line up these squares right here. These squares are just basically alignment holders. And on the replacement charge port, there's going to be a transparent part. Like before, I'm just going to fold this to the side for the time being. But you can see right here at the very top, my hands are a little full, but I'll try. Right here at the very top, we have one part that's transparent and another part that's transparent. And we're just going to line these up over these square bits so that we know that we're not off-kiltered. So this side looks good. This side looks good. Now I'm going to put a little bit more flux over our connection itself. Here we are. Just a little bit. And the reason for is I'm just going to dab one side of the charge port first. That way I can get a free hand. Line. That side looks good. That side looks lined up. All that looks good. I'm going to just dab the bottom down here. It's not going to look pretty at first. Okay. We just want it to be able to hold our charge port in place while we apply some more flux and solder each of the individual points. At this point, I'm going to use my micro pencil with my chisel tip here. This is our FM 2032, and the chisel tip we have, or knife tip, I'm sorry. The knife tip is going to be a T-30 KN, KN for knife, and you'll see underneath the microscope a lot better that this looks just like a knife. See? And what we're going to do is touch each individual connection now. So it would help if we actually had our soldering station turned on to the right one. Yeah, that looks good now. Okay, so like I said before, we'll take our knife. I'm going to use my tweezers just to hold down this pad. We're just going to touch that up, just like that. And just so you can get a better view, I'm going to zoom in some more. And so you can really see what I'm doing here. And what I'll try to do is I'll try to hold this in place while I move the iPod itself. So what we're doing is we're just dabbing these parts, touching them up real fast. And with our tweezers, we're holding down the connection so that the pads don't try to lift up. This is going to give you a nice, clean connection. And so we have these holes. That's just a through hole for the solder on the other side of the connection to touch the solder on top. And there's some parts where we're actually going to have to apply some solder. So like this through hole probably could use some more solder. Up here, these are our clean connections. Well, it looks like actually the solder mounds underneath, there's enough solder for this to come through. We don't have to apply any solder here. You can do this with a normal iron, just to make it look nicer and a nice solid connection. We're just using our micro pencil to get it exact. And so all we did here on the right side of this connector is we used our big iron and just touched it, and it melted this black shield. This isn't actually anything functional. It's just there for aesthetics. That's another thing with using the micro pencil is we're applying less heat, or we're using more of an isolated heat, so we don't have any issues like this happening. So that's okay. That's not going to affect anything. Now that we have our charge port soldered, before we clean it up, let's see if that fixed the issue. Okay, so what we'll have to do is just simply hook up our charger. Oh, you know what? We also need to solder our battery back on. Let's do that. Put this back underneath the scope. And we're going to make all this look pretty when we're done verifying what the actual issue is. So let's cross our fingers and make sure that this is not a logic board issue, that this is indeed just a charge port issue. And what I'm going to do, I'm going to go off screen again. I'm going to hook this up to our USB ammeter just to see if it's charging anything, and if it is, then I'll put it back on the charger down here. The charger down there is just connected to a computer. We need to get some more outlets so that we can actually hook up our USB ammeter to show you what's going on. So I'm plugging in our charge port, and it looks like that was the issue. We are consuming half of an amp right now while it's booting up. And just to verify, I'll show you that it is powering on now with the original battery. I'm going to hook it up to our computer down here. It's very rare for a charge port to fail. It's not impossible. But typically when people come in with charging issues, it's either dust or debris, pocket lint in the charge port, or the battery is bad and just can't consume any amperage. We already confirmed that the battery wasn't the issue. But this was a very rare case of the charge port failing. The charge port was clean. It was spotless. It didn't even look like anyone had gone through and tried to clean it out themselves. Yeah, and we can see right here, the indicator is showing that it is charging. But another interesting thing is, it looks like we may have a 2-for-1 situation. What I mean by that is the battery is showing it's at about 70%. This is the original battery. So when we first turned it on, it was showing that it was trying to boot, and then it went back to the battery loading icon, or battery charging icon. So like I mentioned before, with this generation iPod Touch, this is the 5th generation, and I can't remember off the top of my head when this one came out, but it was over 4 years ago. I know that much for sure. I think the iPod 6th gen came out in 2015. This iPod is just old, so the battery is going to be depleting quicker. Being that we hooked it up to our charger and it turned on, and now it's at roughly 70%, but before we hooked it up to our charger, it would try to turn on and then went back to battery charging. That means the design capacity of this battery has been significantly depleted. It's very possible that only 30% of this battery is usable because it is at about 70% after first turning it on. So we will have to replace the battery as well just to ensure longevity of this battery. If we were to just put the charge port, we kind of would be fixing one issue but leaving another open-ended issue for the customer to have to come back. So we'll contact him and see if he approves doing a battery repair as well. But looking into it, it turns out it is in fact just a charge port issue. Very, very rare for this to happen, especially with the charge port being so clean. So the only thing I could think of is there was some corrosion inside of the charge port. It was just enough to where the connections, we could send a data line or a data signal from our charger to the battery to turn on, but we weren't actually sending any amperage through one of the power lines to turn it on, or anywhere on here. If there's any logic on the other side of here, such as like capacitors or resistors that had failed and caused this to no longer charge. So now we're just going to take a break here and contact the customer to see if they approve a battery replacement. And we're back. All right, so I just reached out to the customer and was unable to get in contact with them. So what we're going to do is just continue the charge port replacement. We'll leave the battery unplugged just a little bit, or we're just going to leave the battery unplugged for the time being and have the screen kind of prepped and ready to go, but we're going to leave this opened up. That way if the customer calls us back or comes back in, we can just see if they want to move forward with a battery replacement or not. So let's get back into this one. So we know the charge port is the issue. We've already desoldered the other charge port. We'll need to unplug the battery again. And we'll look this up. And what we'll do, because we'll have to solder a battery back onto it, whether it's theirs or it's going to be a replacement battery, we're going to go ahead and prep the solder mounds. So those are nice and ready to go for whether they decide to move forward with a battery replacement or not. And we'll leave that alone for the time being. Okay, so we're going to have to remove the battery. And the battery is held in with just adhesive, some double-sided adhesive. So we're just going to take our tool here. This is just a standard black stick, and remove it. And I actually have a question for anyone who does iPod repair on a daily or weekly basis. Underneath the battery is going to be some adhesive, and the adhesive is not what am I trying to say? It almost looks like it's backup adhesive for if this ever needs to be serviced in the future, you then peel off the backup adhesive. So we have two strips of double-sided adhesive right here, but this is the part that confuses me, is right here we have a peel tab and then some black adhesive located underneath this plastic. So is this for if this ever needs to be serviced again, this gets peeled off by Apple service technician and then closed up? Because my understanding, and please correct me if I'm wrong, Apple only services iPods and MacBooks. Let me take that back. Apple only services iPhones and MacBooks. They don't service iPods or iPads. But do their certified refurbished centers, like the one in California and one in Tennessee, do they work on these and refurbish them and put them back on the market? I'm curious to know, what is the sole purpose of this adhesive strip that still has plastic covered over it? I've seen this with every single iPod 5th gen. I think some 6th gens are the exact same way. Anyways, let's get back into this. So looking further into the board, the charge port. The charge port's actually going to go underneath the logic board. I haven't done one of these charge port replacements in about 2 years, so I forgot about this step. So we're actually going to have to move the logic board a little bit out of the way. And we're going to have to detach our... We have a couple of connections here. Looks like we have our speaker in the way too. Okay. Let's pull back out our screw tray so we can keep track of our screws here. And now our screen right here has just a little bit of adhesive on the flex cable. Not enough to where we need to heat it up like we have on all the other ones. Just enough for us to put a pick underneath it and kind of slide it right up. Alright, so our board's going to pick up just a little bit. We don't want to lift it up too much. There's the old board, or old charge port connector. I'm going to bend that. And we take the new one, wedge it underneath here. And now we'll take our screws and put our logic board back in place. The logic board was only held down with 3 screws. Okay, so our charge port's not all the way in because we still have to remove some, looks like a speaker connector, and then pull out the existing part of this charge port. And there's some copper tape that's wrapped around the home button. And we're just going to have to peel that copper tape back so that we can put it back onto our home button. And we'll save that to the side. And then on top of the copper tape, we actually have some Kapton tape too. What are you doing here, Kapton tape? I think the Kapton tape. Actually, let me look at our charge port here. I think that's a flex connection. Is it? It's not. No, it's just covering some logic right here. And we have what looks to be 2 more soldered connections. So that's probably where our speakers attach. I should know this. Okay, no, let's peel our Kapton tape off. Just so that you guys can see, I'm going to put this back into the overhead cam. So the Kapton tape is just covering our logic right here. And we got this mesh, so we can probably transfer this over to the new one. And let's see if we can move this mesh a little bit out of the way. I see where the speaker is soldered down. Okay, so the easiest thing is going to be to remove the speaker. And speaker looks like it's just going to come straight out. Let's get our flat blade in there and just pry from the bottom. Okay. Separate this mesh from the speaker flex cable. And now we'll take the speaker and we'll flip it over to the left side. And there's some more solder joints where our speaker connects to. Some Kapton. So we'll take our iron and just touch this. This should come up pretty quick since it's not connected to any ground. Yep, came up just like that. And we're gonna have to solder that onto our new speaker flex. Alright, so back to removing the charge port. The charge port's going to have some more screws on the left side. Let's try to get this all nice so you can see what's going on here. Tape that down. There. So we need to move these screws. That's a little tight squeeze underneath. Yeah, it's a very tight squeeze underneath here, so I'm not going to be able to do that underneath the microscope. Let's just move this out of the way. And then we have one more screw right here on the auxiliary port. Not wanting to come out though. There we are. There shouldn't be anything else holding this down, so we should be able to pull this straight out. And I say that, and it looks like there's actually a piece of black tape hiding another screw. And that's a very Apple-esque thing to do, just to hide some screws. There's really no purpose for that black tape right there. Just keeping us on our toes. I was going to say, usually an auxiliary jack has about 2 screws holding it down. Okay. There we are. Whole thing came out now. This guy's not wanting to come out. Circles. Sweet. So there's our old charge port. Let's get all ours nice and into position. First, before we install this, I can see our copper tape is on the bottom, so this is probably grounding. And being that it's right next to our home button, it's got to serve some sort of anti-static grounding. But it's there for a reason. Let's transfer it. And is there any mesh on here? Yes, there is. So I almost didn't transfer this, but if you look close enough, this guy looks like that just comes right off. And we're going to put this on to the bottom of our new charge port. Glad I took a look into that. Else we would have had a giant gap underneath the charge port itself. Plugging in. And it looks like the screw holes just line up. Sweet. Now to give us some stability, we can go ahead and screw our left side of the charge port down, as well as our aux port. The right side we'll put down once we get the speaker in. Okay, we'll transfer this mesh off of this guy in a second. Let's go ahead and solder our charge port on. So like all solder points, we need to apply a little bit of flux. And this one I'm going to work really quick, so I won't turn on the fume extractor just for a quick second. Okay, so that one, it's touching, it's not pretty, so I'm going to take my tweezers and push down on the connection. There we go, much better. So our speaker connection's on. Let's clean it up with some isopropyl alcohol. Awesome. And we can float our connection, but before we float our connection, we'll transfer our mesh. We'll transfer this spacer mesh that covers the circuitry to the home button, and we'll put it onto the new one. It looks like it's nothing more than just some Kapton and a mesh, some sort of spacer. And our speaker's just going to fit back into where it was. I'm going to hold it with one finger and then screw in the screw that held it down in place. And we're missing a screw right here in the bottom, but that's going to be on our plate that we originally took off. And then before we're done here, we did also have a little bit more copper right here, and you're going to connect it to the rest of our copper to hold everything down. And that's going to be doing some sort of electric static grounding, probably for the audio since it's right next to the aux jack. Could also be for the home button. It was there for a reason, so we're going to put it back. Sweet. So now that our charge port's in, we're going to have to clean up our charge port. We also need to put some more adhesive in there. I'm going to peel this off just because it is some adhesive. Not sure if it is good adhesive, but I'm not going to strictly rely on that. I'll still put some double-sided red tape in here. So I just cut some thin red double-sided tape. Some 3M red double-sided tape. You can use Tessa tape if you want. Tessa tape might be a little bit overkill for a battery, just in case you ever have to pull it back out again in the future. Red tape seems to be sufficient, especially because that's very similar to what Apple already had in the first place. Now that I think about it, I should have left those strips on. What I'm going to do, just because we may have to replace this battery anyways, I'm just going to leave this out. And it's going to take the same amount of time to put a new battery in as it would to put the old battery back in. So the last thing we have to do is just really clean up our connection until we hear something back from the customer. I won't be able to show that this is all the way put together, just because I'm going to leave this one partly open until we hear back from them. But at least in this video, you've seen that we were able to diagnose what exactly was going on here. We were able to isolate that by testing the battery. The battery wasn't the issue here. The reason why this whole guy wouldn't charge was the actual charge port had gone bad. The logic board was fine, thankfully. I don't like doing logic board repairs onto iPod Touches just because they're not really cost effective. While this is a little bit of micro soldering, it doesn't entail the same amount of troubleshooting as a standard board repair on like an iPhone or an iPad. And then the last thing we do now that we've cleaned up our connections, we're going to take some replacement Kapton tape and cover up our pads. So that's that for the charge port. So the next final steps we'll have to do, which I won't be able to show on camera because I'm going to wait for the customer at this point, is we're going to have to replace the battery, whether with the original battery, we'll put it back in if the customer declines a battery replacement, or put the new battery in. Then after that, we're going to take our EMI shield that we had here. We already have some black adhesive, and that's very similar to Tessa tape. We're going to have to replace that with some new adhesive. Put it down, screw in the connections, close up the iPod. There is a chance that this might even turn on without a battery. The older iPod 4s, even old iPhone 4s, would turn on with just a charger, even if the battery was bad. It just used that little amperage in voltage to turn on. There's a chance this one's not going to turn on just because with an iPhone 5 you require a battery, but let's see if it works for an iPod 5. We have an Apple logo, so let's see if it actually boots up all the way. But this is a good example. Let's see, it's just boot looping. This is a good example just to show that the charge port is talking to the motherboard and it is turning it on. It's not charging anything because the battery's out, so there's nothing to charge at this time. So that was the proper way of how to go about diagnosing a charging issue on an older iPod. The iPod Touch 6th Gen is almost identical to the 5th Gen. The only difference is that it is going to have a newer processor, so it can run a newer iOS. I knew it could run iOS 12. I think it might be on iOS 13, probably not, but the iPod Touch 5th Gen can only go to iOS 9. So that was the process of removing the screen using heat, very similar to an iPad, and then changing the charge port with some soldering. Now, not only is the charge port soldered on, the battery soldered on, and so is the speaker on this one. So not too many repair shops are offering services for the iPods, and most customers, when quoted, don't move forward with iPods just because they are a relatively inexpensive item to begin with. But this guy, he had attachment to it, a lot of music on here, and fortunately the charge port replacement is not too overly expensive. So with that, that is a successful repair until we hear back from the client on what they want to do. The only reason that we are skeptical about the battery is because, to reiterate earlier, when we first tried to turn on the iPod, it would show the Apple logo, then it would show the battery connect to the charging charge port. So we knew that at that point we had some sort of charging issue. When we had the replacement charge port installed, we then had the battery finally turn on, but the battery was at 70%. So typically when someone comes in with an iPhone with a failing battery, the battery will randomly die at a high percentage, 20%, 30%. In this case, this one died at 70%. So if we subtract 70 from 100, that means that only 30% of this battery is usable. The design capacity or the physical full charge capacity of this iPod is only at 30%. Customer might want to just leave it as is because they probably don't want to invest any more into this iPod. They may want to spend a little bit more just to have this one last a little bit longer. But that's why the battery needs to be replaced. The charge port was ultimately the issue why it wasn't turning on or charging in the first place. So that's it. If you have any questions or if you're interested in doing this repair yourself or you'd like to send it to us, feel free to leave a comment below or visit our website at iRevive.com. We do have a mail-in form there to where we can complete the repair for you. That's it for now, and we'll see you in the next one.